Hello, and in this video, we're going to be looking at a complex number loci kind of question. And it says, show on an Argand diagram the locus of the point given by z minus 10 minus 12i is equal to 8. Now, if you remember, we have the formula for the equation of a circle in this form is like that. So we can think of this as z minus, open brackets, 10 plus 12i, like that. Okay, which I think, just thinking, that's how I think about it to visualize where the center is going to be. So we've got a circle which has a radius of 8 and a center at 10, 12. So let's draw just a rough sketch. There we go. And there's our center at 10, 12. And we have a radius there of 8. So that's our imaginary axis, and that is our real axis. Okay, so that's our first sketch there. And that would be all that we need for part A done for 2 marks, which is super nice. This is question 3. Now, we've also got to show the set A is defined by that particular set of criteria there. Now, we've basically got a half line here, and we have a half line. Let's think about the equation of our half line. Our half line, again, is going to be, if we can think about it as the argument of z minus z1. So we've got the argument of z minus, open brackets, 10 plus 10i. Okay, so this is going to be, and it's in between less than or equal to pi over 2 and greater than or equal to 0. Okay, so it's going to have a center. This argument is going to be located from 10, 10. So just a little bit lower than the 10, 12. So let's write that there, 10, 10. Okay, and we've got going up to pi over 2 and from 0. So there's our 0, there's our pi over 2, and that's the region that we've got located by that particular half line. Now, the region that we're after, it says set A is defined by that, shade the region. So they're basically saying it's got to be within this half line, so within that region there between the values of 0 and pi over 2, and it's also got to be the intersection of that and within the circle. So the region in question that is within the limits of the half line and is within the circle is that shaded region there. So that is part B done. Okay, that's that represented, and the region that's required has been shaded. So A and part B. Now, part C, determine 5 marks this bit, determine the area of the region defined by A. I think we'll have a separate sketch here to make this clearer. So let's have a slightly new sketch. Okay, so here's our situation. Now, what have we got? We've got our circle there, which is centered at 10, 12. And we've got the half line, which is starting down here at 10, 10. Okay, which goes like that. And we've got to try and find an expression for the whole shaded area. Now, this bit's fine. That's okay, because that's just a quarter of a circle. So that's just going to be like pi r squared over 4. So that's not really going to present us with any issues. It's this sort of like awkward shape here that's more problematic. Now, I think that people's first instinct here would be to go towards integration, because that's so often what we do, and that could work. But actually, if we were to divide this by drawing a little line like that, then hopefully you can see that what we've got here is we've got a little right angle triangle, and we've got a sector of a circle. Okay, so I'm going to call that angle alpha, and I'm going to call this angle here beta. Now, because alpha and beta, they both add up to make 90. So alpha add beta is equal to pi over 2. So let's think about this then. So what do we know if we can, what can we find out? I'm going to draw and expand a sort of larger view of that, an exploded view of that little section that we're after. So here it is. So that's just a bigger diagrammatic representation of that area. So this is what I've called the alpha. This is what I'm calling beta. That's 90 degrees. What do we know? We know that this must be 2 because the y-coordinate here is 12 and the y-coordinate here is 10. So we've got that that is 2. We know the radius is 8. We know that that is a right angle triangle. So we can find this side here. This is going to be the square root of 8 squared minus 2 squared, which is going to be root 60, which is going to be, in turn, 2 root 15. 2 root 15. Okay, so we found that length there is 2 root 15. Now, we can use trig to find this angle beta, because in this triangle, that's the adjacent and that's the opposite. So we can say that beta is equal to inverse cos of adjacent over hypotenuse, 2 over 8. And when I do inverse cos of that, remember I must be working in radians. I get 1.318 radians. Remember that alpha and beta makes pi over 2. So alpha is equal to pi over 2 minus 1.318. Okay, so that gives me my angle of alpha is 0.25268. Okay, so that's good. We've got our alpha. So we're pretty much set now because we can find the area of this sector is going to be half r squared theta. So a half r squared theta is the area of a sector, which in this case is going to be a half times by 8 squared times by theta, which we've just found that alpha is 0.25, 0.25268. Okay, so we can calculate that bit. And when we do that, that gives us 8.08, 8.08576. Okay, so we found the area of that little sector, so that's good. Now let's find the area of the triangle. That's a half base times height. The base here is 2 root 15, the height is 2. So that is a half times 2 times 2 root 15. That cancels, so that just gives us an area of 2 root 15. So we found that. Now we've just got to do, so we've got 2 root 15, we've got that answer there. We've now just got to do our quarter of our circle, and that's over here. So we've got pi r squared. R is 8, so it's pi times by 8 squared divided by 4, because we want a quarter of that circle. So let's just see what that gives us. So pi times by 8 squared divided by 4 is 16 pi. So that is equal to 16 pi. So we add these three answers together, 16 pi, add the area of the sector. So the quarter circle, add the area of the sector, add the triangle, okay? So that means that our shaded area defined by A, so A is equal to 16 pi, which is the quarter circle, plus the sector, which was 8.08576, plus the area of the triangle, which was 2 root 15. And when we add all of those together, that comes to 66.1 units squared, 3 significant figures. And that is the answer to the area for that question for complex numbers loci. I hope that you found that helpful, and I will see you in the next video.